Hello everyone, welcome to the fourth week of IOQM preparation. We are finally entering geometry. Hello everyone, welcome to this video, and we are going to continue with understanding triangles a lot more. I hope you watched the first video of this lecture series of geometry where we covered everything about point, line and shapes, right? So let's just start away, right? So today we'll actually look at something very interesting. Now look at the triangles in a very different way. That's my attempt, right? So let's first draw a triangle and let's name it ABC. Now, what is the information we get from this triangle? The moment you look at a triangle, what is the first thing first information which you can note? The sides AB, BC, CA, and probably the angles. Angle A, angle B, angle C. Now, what information do we need to recreate this triangle? So, try to look at that. So, we already saw what makes a triangle, right? We saw a relation between this, triangle inequality, and then we saw a relation between this angle sum property, right? Interior angle sum of the interior angles. We saw that to be 180 degrees, and then we saw the triangle inequality, that sum of any two sides must be greater than the length of the third side. Now, how do we even begin to reconstruct it? If I want to make the exact triangle again, what all do I need? For one, we can think if we have all the three sides, right? If we have all the three sides, we definitely can recreate it. Okay, so if I have AB, BC, CA, like sticks or something. If I have sticks of length AB, length BC, length CA, I can just put them together to form a triangle. I can form a triangle and the triangle will be unique. I will form a unique triangle. Now, what does unique mean? If I put the sticks in a different way also, the triangle will be the same. Like it may be rotated, it may be flipped around, it may be distorted in some way, but the shape, the angles, everything, all the properties which this triangle has, that triangle will also have. The area will be same, the perimeter will be the same, everything will be the same. So I hope that is intuitively sound. Yeah, that should not be a problem to understand. Now, what other information makes my triangle unique? Suppose I have all the angles. Angle A is known, angle B is known, angle C is known. We know that. Can I form a unique triangle? I mean, most of you will immediately say it is no, sir. Why? Because suppose I have all of them to be 60 degrees. I mean, in the previous example also we could have taken an example, but anyways. So if I have 60 degrees, I will form a unique equilateral triangle, right? But the equilateral triangle can also have different side lengths. So that means I can have a big equilateral triangle, or a very small equilateral triangle. So all these three are equilateral triangles with only this information. This is not unique. Yes, we can definitely form a triangle, but the triangle won't be unique. For example, in the previous one, if we see that suppose I have AB is equal to 2, BC is equal to 3, CA is equal to 4. First of all, immediately check whether a triangle can be formed. Triangle inequality follows 2 plus 3 is 5, which is greater than 4, right? And 4 is the longest length. So yes, it follows, no problem. So since it holds triangle inequality, there will be a unique triangle with 2, 3 and 4. You can maybe flip it around. You can maybe make this 4, this 3, this 2. I'm not doing this for scale. Don't scale this. Or maybe you can flip it around like this, 2, 3 and 4. All these 3 triangles are exactly the same. They are called congruent triangles. Congruent triangles means it can be overlapped. These 2 hands are congruent. Although they look mirror imaged, if I put them like this, they are exactly overlapping. So that's called congruency. We'll deal in depth with that later, but in today's video I want to build the intuition behind why we use that. Because if you have a deep understanding, it is very easy to solve the upcoming questions. Any kind of questions you can easily solve. That's not a problem at all. Understood? So this won't give me a unique solution. So what else? What else? Suppose I have 2 angles and 1 side. Does that help? Because the side is the problem, right? Here, sides are not unique. Sides are not unique. Because any angles if you take 30, 60 and 90, there can be numerous number of triangles like that, right? Both can have 30, 60, 90, yeah, 60, 30. So this is always possible. So a uniqueness is missing. Okay, let's look at maybe 2 angles. Maybe we know angle A, angle B, and we know the side AB. Yeah, let's say this is, I don't know, 30 degrees, this is 40 degrees, and this is some 5 centimeters. Can we make a unique triangle with this? Let's have a look. Let's see. So let me draw with, well, let me start with the base AB. This is AB. And in the geometry box you also have a protractor which measures the angle, right? So you put it here. So protractor is like this, is a semicircle thing where the measurement of angle is given, right? 10 degrees, 20 degrees, 30 degrees, like this. Here will be 90 degrees, and then again here 80 degrees will be there, 70 degrees. So this is the protractor. So you put that here and you measure 30 degrees and you just extend it like a ray. It should be a ray. And because angle A is 30 degrees, right? And at B, you again make, using the protractor, you make a 40 degrees. And you extend it as a ray. Now, it is almost definitely sure that now Euclid's fifth lemma, so Euclid's fifth postulate, whenever the sum is 30 degrees plus 40 degrees is less than 2 right angles, the line will always intersect. So, using his postulate, we can say that the line is always going to intersect. Now, wherever it intersects, name it C. Now, this triangle ABC is unique, right? You can do it in AB this way, or you can maybe do AB and draw it this way, 30 degrees, 40 degrees, this C, this ABC is also congruent. Or maybe you take B this side, A this side, and do anything. This ABC is also congruent. So all these three variants are congruent. So they are invariant. Irrespective of the rotation, reflection, everything, any kind of transformation you do to the positioning of the vertices. By the way, these are called vertices. This is always unique. So you have two angles and a side. So one thing you must notice is that this AB and these angles are all adjacent. What happens if I have instead angle C is equal to some 50 degrees and I don't have this? Suppose I have this information, right? Suppose I have that information. Then what do we do? So I have angle B is equal to 40 degrees. Angle C is equal to 50 degrees. Yeah. And I have AB is equal to 5 centimeters again. So what do we do? What can we do? You see, we are sure that if it forms a triangle, let me write it down. If it forms a triangle, that implies angle A plus angle B plus angle C should be 180 degrees. So that clearly implies angle A should be 40 plus 50. So it should be 180 degrees minus 40 plus 50. This will be 90 degrees. So angle A will always be 90 degrees. So now we know angle A and angle B and AB 5 centimeters. So we draw AB with a scale 5 centimeter long, and then we draw 90 here, and we draw a 40 degrees there. It forms it will intersect at some point. This we will call C, and then of course C will have 50 degrees, and this will also be a unique triangle. Is that understood? You understood? So what we did so far can be called ASA. In fact, I didn't name it first, but the first one which we did with all three sides, this is SSS. So we did SSS construction. This will be unique. But we saw that AAA construction gives AAA, angle construction doesn't give unique triangle. Unique triangle. But it does give similar triangles, which we will talk about later. And then what did we see? This is what information did we have? Angle, and a side in between. So you see angle A, angle B, and the side AB. So this is angle, side, angle. In that order. The order is important. In congruency or in similarity, in general, when you are doing geometry, when you are comparing two figures, the order in which you name the measurements, the vertices or angles or anything, it's really important. It happens to be a lot important. So this is called angle side angle construction, and this gives unique. Right? And then what do we have? And then here we saw we did not have angle side angle. Instead, what did we have? We had angle B. So let me use this color only. We have angle B and we have angle C, but we have side AB. So we have this side, we have this angle, and we have this angle. This was the initial thing, right? This we constructed later. This was we did later, but it's nothing. This was given. So this is same to same as equivalent to angle side, angle side, right? Or side angle, same thing. In whichever order you have side angle, or angle side, or angle side angle, all these three are same. Please note this point. We will talk about the next one, right? We'll talk about the next one. Okay, so far we used all three sides, two angles and a side, all three angles. So let's try using two sides and an angle. It could be this. Is it the same as this or same as? Okay, I don't mean to be punning here, but I think I hope you understand. Yeah, or are all these three same? Yes or no? Right? That's a question mark. Okay. Now, so we have information about two sides. So let's say AB is equal to 5 centimeters. BC is equal to, I don't know, BC is equal to 4 centimeters. And angle B is given to be, what could that be given as 30 degrees? This information, something like this. Now you see this is side angle side. The angle B is exactly between AB and BC. So this is actually easy to see that if we draw BC and I take angle 30 degrees here, I keep extending it. I take the compass, rounder, compass, whatever you call it. You take the compass, measure a distance of 5 centimeters and cut it. So measure it like this. So take the compass, measure 5 centimeters and cut it like this. So I'm pretty sure this is not 5 centimeters. If this is 4 centimeters, this 5 centimeter will be somewhere here. But the moment you cut it, you got a point which is making 30 degrees with this. So this has to be A, and this length is 5 centimeters. Now you join AC. That will be a unique line. That will be a unique triangle. Now what we used is side. Now I have to change color. So side, angle. This is what we did here is SAS. So SAS construction definitely gives me a unique triangle, right? SAS construction definitely gives me a unique triangle. Now let's look if it is any different from SSA. Let's try to look at it. SSA and ASS are same. Yeah. SSA and ASS are the same. So let's say we have AB is equal to 5 centimeters again. BC is equal to 4 centimeters. And let's say instead of having the common angle B, we have angle A to be some 30 degrees, right? So we have angle A to be 30 degrees, BC to be 4 centimeters, and so that's the situation, and we have angle A to be 30 degrees. So AB. So first let's start with AB. We have AB, and this is supposed to be 5 centimeters. and I have BC, but I don't know exactly what angle it will be. So let's not, so we cannot judge where we will put BC, right? So we will leave it to be later. But first, we know that we have angle A is equal to 30 degrees. So this is 30 degrees. So I'll draw a ray with 30 degrees. Now I take a compass. And I measure 4 centimeters, and I'll try to cut it from B. Taking B, I cut and I get 4 centimeters. But if you do this practically, you will see that there will be another point here which will also be 4 centimeters. Do you understand? This is always going to happen. Always, until and unless there is one particular angle which changes this system totally. So we'll talk about that. But I want you to actually pause the video and take a scale, rounder, compass, everything, and try to do this. 5 centimeter, 4 centimeter, 30 degrees. Try to do that and let me know in the comments what happened to you. Do you get 2 points? Yes or no? Let me know that. Now, this is very interesting, and this gives us 2 points, C1, C2. So we have ABC1 and ABC2. Both satisfy the construction. Both satisfy the given information. Right? So this is not unique. So what did we have? We had side angle in whatever order. I'll prefer this. Side angle does not give unique triangle. Always is the important word. So it does not give a unique triangle all the times, but there is one condition where it does give unique triangle. So let us see what happens if the angle is 90 degrees. Yeah, so there should be a point here such that, let's say we are drawing a semicircle, right? We're drawing a semicircle, we are drawing an arc from here to here, which is of 4 centimeters. So there is this point where this line would cut uniquely, isn't it? I mean, I'm pretty sure the diagram is not at all scalable, but let's see what happens when you have a 5, you have some length such that this is cut uniquely with this angle. If it is cutting so, then you will actually find that this has to be 90 degrees. Suppose we have 90 degrees. A is equal to 90 degrees. Let me draw it accordingly. Suppose my angle A is equal to 90 degrees. And I have side AB to be 5 again, BC to be 4. If this is AB, this is 90, and this is 4, is that even possible? Is that possible? It's not possible. So you have to look at this very, very carefully. Pythagorean triplet won't happen. Come on, the hypotenuse has to be the longest side. So the side opposite to angle A, BC, has to be longest. Okay, so let us take another example. Angle A is equal to 90 degrees. AB is 4 and BC is 5, let's say, this time. So this is possible. You can draw a right angle triangle. this is extending, and this is 4 centimeters, and you have a 5 centimeter, you scale it, it will cut only one time. If you take the compass, measure 4 centimeters, 5 centimeters, it will cut only once. It won't cut twice. So that cutting will happen only when this is 3 centimeters, because this is a Pythagorean triplet now. This is a unique case of, so this is unique case of angle side where angle is equal to 90 degrees. So we call it with letter R. One side will be the hypotenuse. One side will be another side simply. So we call this unique case, we call this RHS. You can again try to make a physical construction on a paper and let me know how it happens, right? So we have the following. So we finally have the following ways of information gives unique triangle construct, right? What are the following informations? 1, side. 2, angle, side, angle. 3, side, angle, side. 4, right angle, hypotenuse, and a side. These are the 4 information which gives us unique triangles, and coincidentally, this also happen to be the criteria. Not coincidentally exactly, because of the same reason that we get a unique triangle with this information, they become the criteria to compare two triangles and say whether and check congruency. This is the criteria which tells us whether two triangles are congruent or not. These are the 4 conditions. Now we will talk about the congruency in the next video in a much more detailed manner. I hope you understood what we did here today. I wanted to bring the intuition to you, right? So yeah, that's all for today. Take care. Bye bye. Meet you in the next one.